This is Course 3, Lesson 51. Today we'll talk about negative exponents and scientific notation for small numbers. Okay, so we've already talked about scientific notation for large numbers, but in order to talk about small numbers with scientific notation, we have to learn about negative exponents. So, negative exponents are exactly what they say. They're just an exponent that happens to be negative, and there is a law for exponents when you're dealing with negative exponents, and it looks like this: a to the negative n power equals 1 over a to the n. Okay, so what it's saying is that if you have a negative exponent, write the reciprocal. Write the reciprocal and make the power positive, or the exponent. Okay. Notice that a doesn't change signs. Okay, so your number doesn't change signs. Just your exponent does. Okay, so let's try this. So 10 to the negative 2 power. So it looks like this, right? A to the negative n. So I need to write the reciprocal. So instead of 10, that will be 1 over 10. And then my negative 2 exponent, when I move it, becomes positive. So if I wanted to go one step further, I could write this as 1 over 100, or I could write it as the decimal 1/100. Okay, this tends to be an area where we get confused. It really is just kind of just this easy. It's just a rule that you have to remember. When you see a negative exponent, it's an indicator that that exponent is in the wrong, or that base with the exponent is in the wrong part of your fraction. So if it's negative in the numerator, if your exponent is negative and it's in the numerator, it needs to be in the denominator. And we'll run into some where you have the exponent is negative in the denominator, and then we need to move it to the numerator. Okay, so let's do a couple problems. First, 6 to the 0 power, that's review. You should have been able to do that problem without even needing any assistance from me. That is 1, because anytime you have that 0 exponent, you have the value 1. And at this point, if you feel like you'd like to try these without my assistance, press pause and then see if you get the same answers that I do. So 2 to the negative 3rd power, that is the reciprocal, right? Negative 3 is your exponent, so I have to write this as 1 over 2 to the 3rd power. And then I can evaluate that. That is 1 over 2 times 1 over 2 times 1 over 2. 2 3 times, which is 1 over 8. Okay, this example, the negative 2 is your base. Okay, so we're still going to notice that we have a negative exponent, so we're going to write this as 1 over, we're going to leave those parentheses there, it's 1 over negative 2 to the 3rd power. And then I'm going to take 1 over negative 2 times 1 over negative 2 times 1 over negative 2, because I need to use that base, that factor 3 times. And 1 times 1 times 1 is 1, but negative 2 times negative 2 is positive 4, and positive 4 times negative 2 is negative 8. And so you can just write that with the negative symbol out there by itself. Okay, these other two examples here are just using the laws of exponents that we already know with negative exponents. So if we have like bases, the 5's are the same, and we have multiplication, then what do we do with our exponents? Bases are the same and we're multiplying, so we'd add our exponents. So this would be 5 to the negative 2 plus negative 3 power, which is going to be 5 to the negative 5th power, so m equals negative 5. In this example, when we have like bases and we're dividing, then we know we subtract. So we're going to take 7, and we always take the numerator number, negative 2, and we're going to subtract that denominator number, minus a negative 6. Remember, when you have a minus, you end up with a positive, and negative 2 plus 6 is going to be 7 to the positive 4, so n equals 4. Okay. Just remember, when you are dividing, that you take the numerator, and subtract the denominator from it with your exponents. Okay, that's how we get 4. Okay, one other problem, and I find these absolutely wonderful to do. The rules with exponents, I think, are really awesome. So we're going to do this problem two different ways. First way, we're going to express with positive exponents and simplify. Okay, first thing you should notice is that there's no symbols in between these. There's no operation indicated, and that means we're multiplying. So we're going to write this as 2. Okay, so the 2's in the numerator. I see some negative exponents, so I'm going to put a fraction bar, because I'm going to have a 2 in the numerator. X over negative 2, that would become 1 over x squared. So I'm not, I can put the 1 up here, but I don't need to. But if you want to see that, we can put times 1 over x squared. And maybe I shouldn't have put the fraction bar up there. Let me fix that for you. Okay, we'll go 2 times, and this is 1 over x, and then the 2 becomes positive, so it's times 1 over x squared, times, this is a y, so that's, I don't do anything with that, times x cubed, because x cubed, these are all going to be in your numerator where you have those positive exponents. And remember, if there isn't one shown, it's a 1, so those are positive exponents. This y to the negative 2 will become 1 over y squared, so I need to write that times 1 over y squared, and then my z goes on the end. And then this is where I could draw my fraction bar so that I have some numerator and some denominators. Now, we've done this before where I'm going to better write that as a z so it doesn't look like a 2, where you know that if you have 3 x's in the numerator and you have 2 in the denominator, if you subtract, you're going to have 1 left in the numerator. But let's write this out. I know I have a 2 because I have no other numbers, so that's going to stay there. And then I have these 2 x's here, so I'm dividing, so it's going to be x3 minus x2, which is x1, and the exponent is positive, so it's going to stay in the numerator. Then I have y's, and I need to subtract, so I have y1, that's a 1 exponent there, minus the 2 in the denominator, so that's going to be y to the negative 1 power. 1 minus 2 is negative 1. Now if I write, I can do this, y to the negative 1, we'll pretty that up here in just a minute, and then z. Okay, now we will not write, so we're going to put a note here that says negative exponents we need to change to positive. So let's do that. I'll go back to red here because we're going to take this and we're going to change it. So the 2 and the x and the z are all positive exponents, so they're going to stay there, 2xz. But y to the negative 1 is 1 over y to the positive 1 power, which is just putting that y in the denominator. And that's your answer. Now, what's the other way that we could have done this problem? Well, let me write these down. 2x to the negative 2y, x cubed, y to the negative 2z. Well, we could have used our properties of exponents right here. I know that I have a 2 and there's no other 2, so I can write down a 2. Now my x's, I have like bases and I'm multiplying, so I add those exponents. So negative 2 plus 3 is 1. So I'm going to put an x. And my y's, when I add those exponents, they're like bases and I'm multiplying. 1 plus negative 2 is y to the negative 1. And z. And then I'm right back here where I just was. So then I write, this becomes 1 over y, and my answer is 2xz over y. Okay, this might create a little difficulty for you to get started, but once you find the pattern and the rhythm behind this math process, I think you'll find that it's actually kind of fun to do. Here's a review. Okay, you already did this back in lesson 28. This was scientific notation for large numbers. And today we're going to talk about small numbers, but I just want to point out a couple things. Scientific notation is still the way that we can write very large or very small, which we're going to do today. The format is a decimal number times the power of 10, and you have to have a coefficient that is only one non-zero number before the decimal, and then times the power of 10. Okay, so remember that that's what we still need to do. It's just now that when we deal with small numbers, the power of 10 will be negative. Because we're making smaller numbers, we need to multiply by a power of 10 that is negative, so that that is actually the same as dividing by 10 squared. Okay, because remember that's 1 over 10 squared, which is the same as dividing by 10 squared. So we're making smaller numbers. So if we start in scientific notation and we want to write in standard form, we have to move the decimal, and we're going to move it to the left, the exponent number of places. Because we're going to divide by powers of 10, which every time you do moves the decimal one place to the left. The other way that you can remember that is that if you have that negative symbol and you can just kind of draw an arrow on it and it points in that direction. So start where the decimal is and move it 1, 2, 3, 4 places, and then you're going to fill in with zeros, but then you're going to write it nice, because we don't write numbers with the little loops under them. So there are 3 zeros and a 3 and a 2. And you can always check, because it's 1, 2, 3, 4 places back to where the decimal was in the scientific notation. Okay, now if you start in standard form and need to go to scientific notation, you have to figure out where you're going to put the decimal so that you have one digit in front of the decimal place, and that would be right there. So we're going to write the number 4 decimal place 59, and we know that we're going to have a power of 10. And now looking at the number that you just wrote down, 4.59, which way do you move the decimal so that you get back to this number? You're going to move the decimal to the left. So that's a negative exponent, plus our number is small, so it's a negative exponent. How many places do we go? 1, 2, 3, 4. 10 to the negative 4. Now I promise you that all of the exponents will not be negative 4s. That's just the way it worked in these two examples. Make sure you count from the decimal point, not from the end of the number, and not how many zeros there are. Okay, that's a short tutorial on scientific notation and negative exponents. Please let me know if you have questions. I will see you in class.